Hey everybody, welcome to the DevCentral Weekly Podcast here for, it is Pi Day, surprisingly enough. Happy Pi Day, Jason.
Thank you. Yes, I have not had a piece of pie yet, but I will tonight.
Yeah. Woo! So on the podcast today, what do we got? We've got a few topics that were thrown up on DevCentral this week. We will kick things off with the acceleration series, which we have been kind of hinting at the last few weeks, but now it's finally started. The posts have started to fly. So we've got a couple of posts by Colin with in project acceleration, starting with the basics.
Absolutely, yeah. I talk about.
Jason?
Yeah, I can talk about both of them. So, yeah, last week on the podcast, we kind of hinted at the beginning of this series. And so Colin starts off, before really even getting into any of the details of web acceleration, just talking about what web acceleration is. And it's just a series of tricks you can do with not just TCP, which we talked about, and compression, but also manipulating the application traffic itself, being able to cache things longer than maybe the web server had indicated that you could, or tell the browser to hold on to objects longer, various different techniques. And so Colin goes over the basics of why even bother doing it. If you haven't, you being the user, if you haven't downloaded like a HTTP Watch or Firebug or some of the tools that allows you to kind of look at the waterfall of your request for a page, you can go out to pingdom.com. They actually have a waterfall tool built in that you can just put in your URL, and then it kind of gives you a layout of your DNS search time, your wait time to first byte, for all the different objects that you download. And so as a web application owner, your customers will go away if you're too slow, or you might not be able to generate as much revenue if it takes customers longer to do transactions. You're out of compute space. The more transaction, or the faster your transactions are, the more revenue that you can generate, and so on. So when you're looking at a web page and there's 150 objects and it's an 11 meg page, that may work on very, very fast links for customers, not going to work so well on mobile. So understanding your application and what it does, and then how tools like Web Accelerator can help you, is always a positive.
Yeah, well, it may work on fast connections, but even fast connections are not immune to browser limitations on number of requests it can make in order, right? So when you've got a large number of objects, that's the one that's very near and dear to my heart. Is you've got 500 objects on your page, but if a browser can only request 2 or 3 or 4 at a time, they've got to go in serial. You're going to have to wait, regardless of whether your connection's fast. You still have latency issues between each request and things. So,
yeah, absolutely, and not just that, but 2 at a time. Your connection may be very, very fast. Your connection to that server might not be very fast.
Right.
And you're right. The longer you are away, the more complicated that becomes for TCP-based protocols, which HTTP is.
Yep. Yes, it is. So that moves us into the second article in the series, which is, I will pull up here, TCP optimization and compression. So we talked a little bit about there. You alluded a little bit to compression, but it is surprising to me. I think somebody had either Colin or Don had pointed out in this article that a large majority of sites out there still don't enable compression, and part of that's historical reasons, because of browser issues with compression and how it handles compression. But if you just think about it, it's like you've got a tube that you got to send data through. If you can make that data smaller, it'll go faster. So compression is good.
Yeah, it definitely good for the website owners because, like for us, an example, we reduced our bandwidth 75% after we turned up DevCentral in the cloud. We went a couple weeks. We had a misconfiguration on our compression profile, and so it wasn't actually applied. And when we applied it, it reduced our bandwidth consumption 75%, which is a big deal when you're actually paying for that bandwidth. If you're in a big enterprise environment and your LAN speeds, maybe that compression doesn't matter, and it actually slows your individual user experience down a little bit because it has to decompress that traffic. But almost always the case, it's a benefit in a wide area.
So what about the argument, Jason, for that, okay, if you're compressing everything, now your client has to go and decompress it, and now you're causing overhead on the browsers, and especially smaller mobile devices that have to do decompression. Is that an issue, performance on the client? Or is the benefit of just compressing it way better than the overhead of them having to decompress it?
Yeah, the benefit is usually always a benefit to the website owner. It's of benefit to mobile users because it gets served faster. So the end user device probably is not going to be inhibited too much by the compression algorithms, and most sites will use a reasonable compression algorithm to where it will compress a little bit but not use such a high compression that it really slows things down for not just devices like Big IP, but also for the client devices that have to decompress it.
Yeah, we also in this article also touched at kind of TCP optimization and compression, but you kind of have to start down at the TCP layer. How can I optimize the connections? Because you've got different types of clients, right? And you have different the application that you're serving up. Is it going off the WAN? Is it going off a cellular network? Is it geared for mobile devices? Is it on an internal LAN where you've got high high bandwidth, low latency, or is it not? What about backend connections from your server to from the Big IP to your backend application? So we talked a little bit about TCP optimization, the lower layer there, right?
Right. Yeah, and there's plenty that you can do. The great thing the great thing about the Big IP is that it's highly customizable for TCP on the client side and server side. So you can have different profiles there to engage those different environments. There's a happy medium in there for most applications, and the TCP LAN optimized profile is a good place to start, even on the WAN side. Some applications don't do so well with that, but that comes back to your testing environment. But the TCP LAN optimized is a good place to start, and so you can see kind of our progression in the article on the client-side connection stack and the server-side connection stack, where we have the base TCP, which is what most virtual servers are deployed by default. I wouldn't recommend ever using the base TCP because it's just, again, it's a starting place, and you can modify from there to get the reason it's not more modified from start is because every application is different.
Yeah.
But I typically start with the TCP LAN optimized profile and then tune from there. And so there's a even more optimized one when you enable Web Accelerator, the WAN, TCP LAN, and WAN optimized profiles, and then we customize it just a little bit more from there. And talking about this initial congestion window size, this is for the congestion control algorithms within TCP. The initial start where I'll spin up real quick and then kind of level off if there's some congestion issues. It allows you to tune that initial congestion window size. And I threw a graph in there that kind of talks about in the link to the articles where the graph came from about setting the congestion windows, and you don't want to get crazy with that because it'll really slow things down if in lossy networks over latencies of 200 milliseconds or higher. So there's a lot of customization that you can do with TCP, but you want to test everything because application by application, it makes a big difference.
Yeah, a lot of stuff there. That low-level configuration thing, I'm glad you understand it all. And it seems just like, it's just kind of trial and error, right? What kind of tools are folks using to, like, if somebody's coming in and saying, hey, my application's kind of slow, you've got all these configuration parameters. You kind of need to be a Wireshark guru to be able to break packets apart to be able to figure out how to optimize these things. So you think the best bet is just going by like our TCP WAN and the other profiles until you see an issue, and then try to do subtle tweaks?
Yeah, I would definitely use one of the optimized profiles from F5 if you're not really familiar with TCP. And I'm learning things about TCP all the time. There's a lot of intricacies where you might understand one feature, you understand another feature, but those two features together exhibit behaviors that you wouldn't expect. And so it's definitely an art and a science.
Yep. So that is our first 2 series on it. We've got a whole slew of them, right?
Yeah, we got
coming out?
8 more articles in the series, right. And another 2 next week.
Be on the lookout. We will probably be talking about those on this the podcast next week. Next in line here is a blog from Don McVitie, and it is titled "What You Read Says a Lot About You." All right, let me pull this post up here. What you read says a lot about you. And he's got a big photo of a bookcase full of computer books. So when I was reading through it, I'm like, okay, where's this article going? And I think he discussed a lot of things in this article. It's about, hey, if you look at somebody's bookshelf, you can kind of get a glimpse on their personality and their interests and what they're into. He discussed what he and Lori have read over the years, and that he's got something like, what did he say, 3 shelves and another closet of 3 books deep, and shelves every 12 inches, and they're in the cleanup process. So what do you get rid of over time?
Yeah.
And some of these books, some things now, are going electronic. So the question is, when's the last time you actually bought a computer book, or when are you using the internet to learn things, or are you getting ebooks on your Kindle or your iPad or your devices or your computer?
Yeah.
When's the last time you bought a book, Jason?
Last week, actually.
I
bought. Last few weeks, I did buy the iRules book that What Lies Beneath, Community User. What Lies
you bought
Beneath
it?
Put out.
Okay.
Yeah, I bought that, and so I bought that, and I'm flipping through that, and also I got Headfirst HTML and CSS. I use this one just came in the mail a couple weeks ago.
Okay.
And also HTML5 programming, which I know the purists out there will say HTML5 is not a programming language. It's a style thing. So I'm not even going to get into that argument. But I use HTML a lot. I'm exposed to CSS a lot in JavaScript, but I don't know that I fully have my head around how all of it functions and works together. So I bought a couple books just to kind of dig in and read, and I have a whole library of Cisco print or Cisco press books back from my CCIE attempt days, and I used to be the hardcore routing and switching, and so that was where I lived, and so I still have them all up there. I've got some Ruby on Rails and Python and other. I've got a couple PowerShell books that I flip through when I'm trying to understand what all your scripts do, and so. I buy a book every now and then. I'm trying to think what was the last one I actually completed front to back. It's probably Mastering Regular Expressions. That book was really good, and I have not mastered regular expressions yet.
I was going to ask if you made it through the book. That's probably a good first step, but I don't think anybody's ever really mastered regular expressions. It's like anytime I come up with somebody shows me I tend to think I know regular expressions pretty good, but you'll get one and it's like, what is this doing? And I even talk to people, showing other people who are very good at regular expressions. It's like when you go and you attack and start writing one, it's like, okay, I'm going to whack this together and do something. It's kind of like me writing Perl. It's like I have no idea what a hash or array or these things are, but I know if I put the @ sign before it works. So
yeah, I think that's everybody writing Perl. Sorry, Colin.
Yeah, we don't have Colin here to defend himself.
Yep.
But yeah, as far as books on my front, I bought a few PowerShell ones when I was first starting to learn it. But of course, back in college, all the books that I was using in courses to learn programming. But in general, I think I can't remember a technical book that I've bought that I've actually read all the way through. It's been more of, I need a quick reference guide, so I'll look at the appendix and the references, but more and more, it's all online. It's like with blogs and tutorials and APIs all online, and it's just quicker for me to get up and going. I'm kind of attention deficit problems with regards to reading. I want to get my hands dirty, so usually when I get books, it's either way too easy or way too beginner, where I can't actually learn what I need to learn right away. I don't have the patience to learn the underlying things for every aspect of the language. I want to learn what I need to get done to get it done. So maybe that says something about my personality too.
Yeah, a lot of what I find online, but with things like that are very, very common, HTML, there's so much out there that it's hard to find a concise guide to put all the pieces together for me.
Yeah.
Like I can find it to like solve a problem, and it's pretty good to like if I'm trying to get some feature or whatever to work, I can find that. But as far as building overall understanding as to what I'm doing instead of actually the implementation of it, it's lacking for me sometimes.
Yeah, well, to each his own. Kindle, or I guess books are still out there. They're still selling. So
I have an e-reader. I've got a Nook, and I've got the Nook app on my iPhone. I still prefer, like when I'm reading for understanding, I still prefer to have something in my hands.
Yeah, I haven't gone the ebook route either. If it's something I can find online that I can bookmark, that's one thing. But there is something to be said about having a piece of paper you can flip through, take notes on, put bookmarks in, little sticky notes, and but it is hard to cut and paste out of paper. So
that's for sure.
All right, so we can move on to our last topic here, which is David Holmes was just. Let me pull the screen here. Let's see, supporting elliptical curve cryptography. Yeah, so David was at the RSA conference, I think it was last week or the week before, it was just recently, and he was asked to sit on a panel with Symantec and Akamai. And the subject of this panel was elliptical curve cryptography, ECC, which is Symantec is kind of coming out with here, and there's lots of benefits to this, and there's different forms of cryptography that have I'm not an expert, so I'm not going to get into the mathematical optimizations for the different types of cryptography systems, but the goal of this one, I think, is that it's basically using elliptical curve math and mathematics to complexify, if that's a word, but also simplify the amount of processing it takes to make data more secure. So Symantec's come out with this proposal that actually was proposed by a couple authors early on, it looks like at the same time, Neil Koblitz and Victor Miller in '85. So the proposals have been out for a while, but it looks like they're starting to make their way in. The things I see that's pretty interesting with this is that basically they're making a comparison that they can say a 256-bit elliptical curve key should provide the same security as a 3K RSA public key, which is craziness in as far as difference on the client processing, and specifically when you start approaching enabling crypto in different devices, in smaller devices, in virtual machines, things that in the past just couldn't handle that amount of processing. I don't remember what they say, going from like a 1K key to a 2K key is something like 20 times more processing. 8x.
Yeah, it was a theoretical 8x. It was a little bit maybe more than that in practical implementations.
But then 2048 to 4096 is something crazy, right?
Yeah, the math gets a little scary there, but yeah, with the ECC, the bits are so much smaller. In fact, I was doing a little bit of research, and they said the RSA Diffie-Hellman key length compared to an ECC key length of 128 bits for like a 1024. It's like a 10-to-1 computational efficiency with ECC, and so you get the benefit of needing less compute power, less memory. It's faster. Some of the risks, I guess, and they address it a little bit on that panel with some implementations of it. But one of the reasons it was not as fully adopted is some of the legal issues with patents. And but I think between RSA and this is kind of like the Blu-ray and HD DVD.
Yeah.
The industry is going to pick one, and they're going to go that way. And but now with as big as mobile is in the virtual space, I think that'll get readdressed, and it is starting to get readdressed by the industry.
Yeah, and it looks like David had mentioned that we will be supporting. He commented, so I guess I can comment that F5 intends to roll out support for it in the next few releases of Big IP. So it should allow support into the future for Big IP supporting this, and it will definitely help with our VE. So that's been one question customers have asked me when they're asking about VE and large SSL. Throughput sites where we're doing a lot of SSL offload is, will VE be able to handle it, or will the VMware infrastructure be able to handle that? So if you can provide more security for less computation power, that's all good.
Right, absolutely. And one of the other things, I guess, is browser support, and I might have missed it on the call, but I think that they said the browser support is not there yet. But in time. If they build it, if you build it, they will come. Right?
It means either Google or Chrome will come out first, and then you got a few years for IE, and so we're a ways off. But now, is this something, Jason, that can sit side by side with RSA, or is it's one or the other? You pick and choose.
It'd be a fork. I mean, it can sit side by side from a virtual server to virtual server perspective, but yeah, it wouldn't be something that would be. I don't imagine it would be something that would be supported at the same time on the same virtual, but that's a good question. I don't know.
So how does a browser just not work? If we rolled this out on our website and somebody connected with a browser that didn't support it, they just get no connection? They're out of luck?
I think that the handshake may, honestly, I don't know, but I would imagine that any kind
we should add David on this call.
Yeah. I think that any kind of a migration strategy would include some backwards compatibility, but I don't know that to be true.
Because I know that with RSA cryptography, you can fall back from a 4K to a 2K
right.
if you choose to go that route. But I just don't know how it works if you're going elliptical on one side, and can you fall back to an RSA? I don't know.
Yeah, I'm sure there would be a mechanism in the initial exchange, the initial handshake, that would be able to determine the version IDs, and maybe if it was like TLS v 1.3 and it was using different technology, then that they would be able to identify that somehow. But I haven't looked at the specs, so I'm speaking ignorantly.
I know I haven't either. So, of course, I like throwing questions out that I don't know the answers to, and nobody else does. But they're good questions to have. Anyway, so I think that's it for the podcast this week. It's all the topics we have.
Well, we do have the feature of the week.
Oh, we do. What is that?
We do. The
feature of the week we have to get on too. So at 11.
Oh well, I'll be fast.
So let's go a quick feature of the week.
The feature of the week is the database variables, and so the underlying TMOS system, you have the ability to set these different database variables that turn things on and off. Sometimes they'll introduce a new feature, and they'll do that via database variables initially before they roll it into some kind of a command line configuration or GUI-based configuration object. They did that with the TCP options flags before they productized it. It was done via database variables. But some of the database variables I use consistently, the bigd.debug variable that allows you to enable more logging for your monitor traffic. And then you obviously wouldn't want to leave that on all the time, but it gives you a very detailed look at your monitor traffic. Live install.saveconfig and moveconfig, those database variables allow you to not move your configuration or license forward into a different boot slot. So for whatever reason you want to start clean, you can build a new image. And then tm.rstcause.packet gives you the ability to insert the reason you're getting a TCP reset into the packet. So if you're using Wireshark, well, why'd that get reset? It would actually give you that reset info in the packet, which is cool. So I use those when I'm doing troubleshooting. GTM.querylogging gives you enhanced data into what GTM's doing with requests and what its responses are. A lot of different variables in the database. You can look it up on Ask. There's a couple solutions, 11.740 and 13.455, that cover the various database variables and what you can do with them.
Sounds good. Yeah, cool. My from an iControl standpoint, I always point this one out. iControl.log level is a good one if you want to do if you're building iControl applications. Set that to debug, and it'll just give you methods. If you set that to trace, it'll spit out the whole SOAP request and response from the server side. So there's one that not many people know about. We don't really document it, but it's good for debugging, especially if you're doing a client where you're custom forming the payload, the requests, or like Perl where it's more loosely typed languages. So it's one of my favorite ones.
Cool.
All right. Well, that is it for the DevCentral Weekly Podcast this week. I think I'll get it right this time that we're actually finished, unless you have any more other topics that I missed.
We are done. Yes.
Okay. Good. All right. So we'll see you again, I guess, next week.
All right. Sounds good.
Thanks, Jason.
All right.